So in this video, we're going to begin talking about limits that approach infinity. And by that, I don't mean when we write limit as x approaches infinity. I mean we're going to have the limit as x approaches some number c of a function f of x, and then have the limit be infinity or negative infinity. So to begin, we should review what we mean by what's being asked. So this question has to do with vertical asymptotes. And so we should review how to find vertical asymptotes given a rational function. Vertical asymptotes can only happen when we have rational functions. So a rational function just means it's going to be one function over another function. So really it could be anything. It could be 2 over x, or x squared plus 3 over x to the fourth plus x. It could be really anything like that. So for this example, I have it in factored form. And so we should go, and now let's go over sort of what does each expression mean. So there are 3 things you can find when given a rational function, and that is vertical asymptote, zeros, holes, and then horizontal asymptotes, which I've gone over in previous videos, but I'll review really quickly here. So a vertical asymptote occurs when there is a 0 in the denominator that is not in the numerator. So for this function, that would be right here, x plus 5. X plus 5 isn't present in the numerator, but it is present in the denominator. And if we sort of solve for x here, we get x equals negative 5. So there is a vertical asymptote for this function at x equals negative 5. Next, let me just color code all this. Next is 0. A 0 happens when there is a 0 in the numerator, but not in the denominator. So if you look at this function right here, we see that this would be, this should be at x minus 2, which if we solve for x is x equals 2. X minus 2 isn't in the denominator, so at x equals 2, the function is going to equal 0. Then a hole occurs when there is a 0 in both numerator and denominator. So this would be right here, x plus 3, because they are both numerator and denominator. So if we solve for x here, that's x equals negative 3, because we're just looking to see when these sort of mini equations, x plus 3, x minus 2, x plus 3, x plus 5, when that equals 0. So it's going to equal 0 at x equals negative 3, and there's going to be a hole there. And then there's a horizontal asymptote, and if you don't remember how to find horizontal asymptotes, it's just taking the highest power in the numerator and the highest power in the denominator, dividing them, and then whatever that number comes out to be, if there is a higher powered x term on the top, so if it's, say, you factor in, it comes to be x over 2, there's going to be no horizontal asymptote. And if you get something like 2 over x or 1 over x or anything over x, then it's going to have a horizontal asymptote of 0. So if we FOIL both of these equations, we're going to get x squared plus x minus 6 over x squared plus 8x plus 15. And then we take x squared over x squared, that's going to equal 1. So horizontal asymptote is going to be at x equals 1. And so what we're really going to focus on here is the vertical asymptote. So I have this equation graphed on the side. I'm going to put it right here. And so if we're not really aiming to graph this, we're really looking for the vertical asymptote of this function. So let's go to x equals, x equals 2, negative 3, negative 5. This isn't, the best drawing, but that's about right. So this function's gonna look something like this something a bit like that. So as you can see, there's a vertical asymptote at x equals 5 and a horizontal asymptote at y equals 1. Oop, that would explain why I was a little confused there. Y equals 1. So now let's say I want to take the limit as x approaches -5 from the left. Remember, this negative symbol means approaching from the left of f of x. So what is this going to equal? Well, if we look at the graph right here, you can see that as x approaches -5 from the left, it's going to get infinitely positive. So the answer to this limit is simply positive infinity. And then if I were to ask the reverse, limit as x approaches -5 from the right, well, from the right, it's going to get infinitely negative. So the answer would be negative infinity. And these are both correct answers for these limit problems because we're asking for the vertical asymptote and what it's going to be approaching at a singular point. So infinity and negative infinity are just sort of abstract answers as a way of determining what the value is going to be, because there's no real value. It's an infinite value. It could be infinity or negative infinity. Now, what if I was to ask, what is the limit as x approaches -5? Well, the limit from the left and the right, infinity and negative infinity, they're both different. Because these are one-sided limits, infinity and negative infinity, they're okay as answers. But as we're approaching -5, it's different from both sides. So there is no limit. So the limit does not exist. And so from a graphical perspective, this is a very, very, in my opinion, much easier to grasp than the horizontal asymptotes and how to solve them. And solving this is a lot, so much easier than with the horizontal asymptotes, and you're going to see why in the next video. This is just a graphical understanding of it. In the next video, we're going to go over how to solve this algebraically.